I want to show a way that if it's in the shorthand question, you don't have to balance the whole stuff. Just on this, it's also based on the understanding of our Nerst equation. Can we do something here? So I did not balance the whole stuff. Under this calculation, for the constant is a constant. E cell, which is part C, we did this by flip one of the redux, and we already have the 0.18. So this one is 0.18, well, it's positive voltage for the constant. The only variable here is how many electrons being transferred, right? Okay, this is the one that I haven't really balanced. Let me do this. Okay, see if you can see there are, so how to get from positive 7 to positive 2, that will be gain 5 electrons, right? Okay, how do you get positive 3 to positive 6? That will be lose 3 electrons, right? Okay, in order for me to get, since each time I can only do 5 per batch, each time I can lose 3 per batch, I overall need to cancel all the electrons, because based on our, let's say, graph, from one electron node, all the electrons give out, like 3 electrons out, it's all being received by the others. So you got to have the same amount of electron transfer. How much electron that is being lost? You can have a multiplier. You can have a multiplier of this overall. Let's say, let's times a number, okay? This one can have a multiplier times a number, but overall this two should cancel because electron is intermediate, right? So I do see electrons here gain 5, lose 3. But overally, they should not see our overall. They should not show up in our overall. Okay, just by figuring out how many electrons, since each time is by batch of 5. This is by batch of 3. We can find if I would need at least to multiply by 3. This one at least to multiply by 5. That will be at least. In order for all the electron that's lost by chromium can be received by manganese. Are we cool with this? Okay, there's another tricky part of this is, since I have 2 chromium here, this will have to be, so in order for each of my positive 6 to exist, I cannot just have half of them. I will need to have 2 chromium, so each time it's actually lose 2. So that will be 6 electrons. So instead of multiplied by 3, it's multiplied by 3 times 2 equals to 6. That's how I figure out how many electrons being transferred without actually balancing the whole stuff. So this number is 30. Yes. Okay, 6 times 5 equals to 30. This n is 30. So you don't have to balance, unless we ask you to balance. But you can figure out how many electrons being transferred. If it's in a, let's say, multiple choice, I think that will be a quick way for you to do that. Cool? And this is also, I will refer this one as, do you have a good understanding of how the reality of redox is transfer of electrons from one side to the other? Are you cool with this?